Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so I got some requests for 3 questions, so I want to deal with that first of all. A student contacted me. The first thing they said was that the volume on the YouTube videos was really quiet, and I looked at them myself and didn't find that. If any of you listening have experienced that, would you please email me and let me know? I want to try and figure out what the problem is with that. But anyway, the other thing, this student said something about this particular problem, but I don't know if they figured it out because I don't see any difficulties with it. So if you are that student, you know who you are, contact me again and I'll go through it with you, but it looks to me like you've got things just fine. Okay. Let's stop that and go back to this for a minute. I've got another thing I need to get up here for a student. Okay. 5. Let's see here. All right, number 5. Okay. So this particular problem, number 5, I was looking at the answer that the student put in there and I thought, well, I don't see what's wrong with it. And I thought, well, maybe it had to do with the notation of the powers and everything. But what they were actually looking for was to say that a 3 terms is a trinomial, 1 term is a monomial, and 2 terms is a binomial. So the person did some good examples of those here, but apparently they were just looking for the names of those polynomials. Anyway, that takes care of that one, hopefully. And then number 25. Let's see here. Where are we? Okay. Now, at first, this problem may look rather complicated. You've got this square piece of paper. You've got to cut out these sides, and it's got the total volume and everything. But let's read it and see what it really wants. It says the polynomial 4x cubed minus 42x squared plus 110x gives the volume in cubic inches of the resulting box when a square with sides x inches long is cut from the corner of a 10-inch by 11-inch piece of cardboard. Find the volume of a box if 3-inch squares are cut out. So it seems like it might be really complicated, but all they really want us to do is to take that polynomial 4x cubed minus 42x squared plus 110x and evaluate it when x is 3. Okay, so having said that, we'll get rid of this, go back here, take a look at my whiteboard screen. So if x is 3, we're going to have 4 times 3 cubed minus 42 times 3 squared plus 110 times 3. If I punch that all into my calculator, 4 times 3 cubed minus 42 times 3 squared plus 110 times 3. Let's see if I did that right. 4 times 3 cubed minus 42. I get 60. And I think it was inches. I don't remember. But anyway. Okay. Let's see here. I think that's right. So all they were asking us to do was to evaluate this polynomial when x was 3 inches. Okay. Before we go on to the next section, are there any other questions that people didn't notify me about ahead of time. Anything that you have right now.
I have a question on math, I believe 4 point, or I think it's 5.5.
Oh, okay. Well, that's what we're going to be looking at today.
Okay.
So
It's just the last one I didn't get on number 21.
yeah. Tell you what, if we have time at the end, I'll look at it, but generally I don't take class time to do problems for students that are working ahead. I'm glad that you are, that's great. But let's see if I have time, you remind me at the end and we'll look at it, okay?
Okay, no problem. Thank you.
All right, you bet. So section 5.5 has to do with adding and subtracting polynomials. All right.
Oh, this is going to be fun.
Well, actually, if you took Math 85, you already kind of did this back in chapter 2 when you combined like terms. And let me show you the difference between what we would have done then and what we're going to do now, okay? So back in 2 point, I don't know, whatever section it was, we'd have an expression like 2x plus 3x squared minus 7 plus 4x squared plus 6x plus 18, okay? And it would say combine like terms. So we'd put the x squareds together and get 7x squared. We'd put the x's together and get 8x. We'd put the constants together and get plus 11. And notice I put them in decreasing powers of the variable, otherwise known as standard form, okay? So that's back then. Now, how would that be different from what we would be looking at today? We'd have this, we'd have the polynomial 3x squared plus 2x minus 7 plus the polynomial 4x squared plus 6x plus 18, okay? So instead of them just being single terms, we've got groups of terms. We've got 2 trinomials that we're adding. So here are the rules. If you have a set of parentheses and there's nothing out in front of it, that also means there's an implied 1 out in front of it. And if you distributed that 1, basically what you would get is what's inside the parentheses. So you'd get 3x squared plus 2x minus 7, okay? If you have a plus sign in front of a set of parentheses, that's like plus 1 times it. So again, you would distribute the 1, so you'd basically get plus whatever's inside written as it is. Then you'd go back and combine like terms. You'd get 7x squared plus 8x plus 11. So there really isn't a whole lot of difference with what we're doing here compared to what we would have done back in a previous math class. Now, when you're adding polynomials, things are nice, just like we've done here. It's when we're subtracting polynomials that things get a little bit trickier. And let's see. I'm going to go ahead and do one example of that. Then I'm going to go back and kind of work my way up to it. But just let's say we have this situation. 5m squared minus 8m plus 8 minus the quantity negative 20m squared plus m. Oops. Okay. Now, as I mentioned earlier, if there's either a plus sign or no operation symbol at all in front of the polynomial, basically we just recopy the polynomial, but we can get rid of the parentheses, okay? This is where things get different. If we have a subtraction sign in front of a polynomial, we need to distribute that subtraction sign. It's like taking -1 times everything inside. And what that does is changes the sign of each term inside. So we get plus 20m squared and then minus m. So negative times negative makes it positive. Negative times positive makes it negative. Then combining like terms, 25m squared minus 9m plus 8. So that's where things are a little bit different. Any question on that? All right, let's go back and just look at some more examples of addition, and we'll get to subtraction as well here. Let's see here. 15x squared plus 10x squared. It says simplify each polynomial and write it in descending powers of one variable. Well, in this case, you could look at it as, well, we're adding two monomials together, but they are like terms. So we get 25x squared is our final simplified polynomial. As far as descending powers, since there's only one term, that's it. It's just 25x squared. Okay. Now, let's say we've got this situation. 17y squared minus 22y minus y squared. And again, this is very much like chapter 2, combining like terms, 16y squared, y squared, minus 22y. Those are not like terms, so we've got a binomial in descending powers or standard form. Any questions about that one? All right. Negative.
I actually
Yes?
do have a question.
You bet. Go ahead.
By descending powers, they mean the term with the highest exponent goes first?
Yes, exponent on the variable. So we look at the variable and the highest power of the variable, then the next highest power, et cetera, et cetera. Yeah.
Okay, thank you.
Mm-hmm.
And you can't mix the, like let's say it would have been 22y to the third power, it would have been on its own because it's not the same. So you can't add them together, right?
Correct.
Okay.
Yes, yes, yes. Okay, we good? All right. Now let's see what do we got here. Negative 3y squared minus y minus 6y squared plus 7y. So these are like terms. Negative 3y squared minus 6 more y squared would be negative 9y squared. And then minus 1y plus 7y would be plus 6y. So that would be the final binomial in standard form. Questions there? All right. Now things are going to get a little bit trickier. We're going to deal with some fractions. Just remember, fractions are fun. Keep saying that. Fractions are fun. Okay. 1/5 x squared minus 3/8 x plus 2/3 x squared plus 1/4 x. All right, so we've got some like terms. These two are like terms, and these two are like terms. Let's take the two terms that are x squared and put them together. And then we'll take the two terms that are just plain old x and put them together, okay? So now I'm going to focus on this piece, and then we'll get to the second piece in a bit. So if I've got 1/5 of something plus 2/3 of the same thing, to add those two fraction coefficients, I need a common denominator. So what is the least common denominator of 5 and 3?
That would be 15.
15, right. So I need to make this into something 15th x squared plus something 15th x squared. But I want to take 1/5 and write it as something over 15. So I'd have to multiply the denominator by 3 to get 15 in the denominator, which means I'd also multiply the numerator by 3. So my new numerator is 3, because 3 over 3 is 1, and I can multiply times 1. I'm just writing it as 3 over 3. So 1/5 x squared becomes 3/15 x squared. Any questions about that? All right. Here, I need 2/3 to be something over 15. So I'm going to multiply the denominator by 5, which gives me 15 in the new denominator, which means I'll multiply the numerator by 5 and I get 10. So 2/3 becomes 10/15. Now that I have two fractions with the same denominator, I add the numerators over the common denominator. So 3/15 x squared plus 10/15 x squared becomes 13/15 x squared. And 13/15 as a fraction cannot reduce. So I'm done with that part of the problem. Any questions before we go to the second part? Okay, let's look at this piece of the problem now. So what's the common denominator between 8 and 4?
That would be 8, right?
Right. So if it ain't broke, don't fix it. So -3/8 x stays -3/8 x. 1/4 x is going to be something over 8 times x. So I'm going to multiply 1/4. Let's see, I'll multiply the denominator by 2, which gives me an 8. The numerator by 2, which gives me a 2. So 1/4 x becomes 2/8 x. So now I've got two fractions with the same denominator. So -3/8 x plus 2/8 x would be -1/8 x. And here is the final answer in descending powers. So a lot going on there in terms of fractions. Any questions on this problem?
So how come you, for the first part, it was 1/5 minus 3/4 plus 2/3, or how come on the bottom it was minus? Like for the next,
Here,
yes.
that came from right there. I rearranged the terms. I put the terms, I took this term and this term and put them together because they were both x squared. And then I took this term and put them together because they were both x. So this term went over here and this term went over there. That's why the sign switched, because I moved the terms.
Okay.
All righty. Anything else? Okay. Let's see here. Let's do one with decimals. 1.9 m to the 4th power minus 2.4 m to the 6th power minus 3.7 m to the 4th power plus 2.8 m to the 6th power. All right, so these are like terms and those are like terms. We're going to put them in descending powers. So let's deal with the m to the 6th power first. Well, if you've got minus 2.4 of something plus 2.8 of something, that would be like 2.8 minus 2.4, which would be 0.4. So I've got 0.4 m to the 6th power. Okay, so this combined with that gave us that. And then I've got 1.9 m to the 4th minus 3.7 m to the 4th. Well, if you've got 1.9 minus 3.7, you're taking away more than you have, so you're going to be in the hole or have a negative answer. And I don't know if you remember how you go about that, but you can change subtraction to addition of the opposite. When you're adding two numbers with different signs, you subtract the smaller absolute value from the larger. So basically you get this, and that becomes 1.8. But because the largest absolute value was negative, you end up getting negative 1.8 m to the 4th. This is okay. So your final answer, 0.4 m to the 6th minus 1.8 m to the fourth. And if all else fails on your calculator, take 1.9 minus 3.7 and you get, oops, I typed in the wrong thing. You take 1.9 minus 3.7 and you get negative 1.8. So that's where I get that coefficient. All right with that? Okay. A couple of things I want to mention while I'm thinking of it, since we're dealing with decimals here. A situation that came up a number of times from students, and especially on the tests, it's like for some reason they didn't catch that during the homework. But if you've got a fraction that you're supposed to enter, like let's say 4/3 right here, okay, and you take it and punch it into your calculator and you get this. Let's see here. Okay, and it just keeps going. That is not the same as 1.3. 1.3 is 1.3. 1.3 repeating that 3 keeps going on and on and on. Avoid that situation. Use fractions. Also, 1 1/3 WebAssign doesn't tend to like mixed numbers. So you want to give an exact answer. If it doesn't come out as an exact decimal, don't round it off, stick with a fraction, okay? The other thing had to do with graphing. I went over numerous times about how you have to graph on WebAssign. And I guess I want to say this about that. And here I'm, you know, you folks are getting this information, so maybe people that watch the YouTube video will pick up on this. Even though it's not required that you attend this meeting, you are responsible for everything that goes on in this meeting, meaning that if you're not attending the meeting and you're not watching the YouTube videos, you're not going to know how to do some stuff. And again, I know I'm telling you and you're here, but maybe there'll be some people that haven't been watching that will start watching and they'll hear this, okay? Because I went over how to graph, what to do, how many points to use, and yet still a number of people did it incorrectly. Okay, enough nagging, moving on. Let's see here. This says, add the polynomials. So I've got the quantity 3 cubed squared minus 5q plus 7 plus the quantity 2q squared plus q minus 12. So I had a similar situation earlier. I've got nothing in front of the first one and a plus sign in front of the second one. So I'm going to drop the first set of parentheses, 3q squared minus 5q plus 7, distributing the plus sign in the second set of parentheses. It doesn't change anything that's inside, so I get that. Now that I've gotten rid of the grouping symbols, I can combine like terms. 5q squared minus 4q minus 5. What you don't want to do is start combining like terms that are in different groups. Now, in this problem, you would have gotten away with it because there's an addition sign there, but let's not focus on what we can get away with. Let's focus on what we should do to do it correctly. And when this is a subtraction sign and you do things like combining things in different groups, things are definitely going to be wrong. So there's an order to this madness. All right. Let's see here.
I have a question.
Yes.
So when you're doing descending order of powers, what happens if you have two different terms with the same power?
Are they the same variable?
No, if they're different variables with the same power.
Then things get messy. Yes, good question. So in fact, let me see. See if I can find one here. Yeah, here. Okay. Let me deal with that in the context of a problem. Okay. And then if it doesn't answer your question, tell me and I'll go into more detail. So I've got mn plus 8n squared minus 6 minus 5mn, and then plus n squared. Okay. So first of all, I'm going to get rid of the grouping symbols. There's nothing in front of the first parentheses, so I can just drop the parentheses. Then I'm going to distribute. So I'm going to get minus 6. Negative times negative is plus 5mn, and then minus n squared. Okay. Now, these are like terms, and those are like terms. So I've got 8n squared plus 6mn minus 6. Now, term by term, the degree of 8n squared is 2. The degree of 6mn is also 2, because you'd add the one that's implied on the m and the one that's implied as the exponent on the n. So then the question is, well, which one's standard form? Okay. When you've got more than one variable, sometimes you can't put it in standard form, or sometimes you just have to pick a variable and say, well, let's go with n. For instance, in this case, if let's say I choose n as my main variable, this would be n squared, n to the first power, no n at all. So this would be in standard form in terms of the variable n. All right. Now, let me look at another example. Well, did that make any sense?
Yeah.
Okay.
Mr. Mayo,
Yes.
I think you might have done n squared wrong, perhaps. I think it's supposed to be a 7.
Yes, it is. My bad. Thank you. Thank you.
No
Thank you.
worries.
My problem, and you'll hear me say this all quarter long, it's not an excuse, it's just the truth. I'm always looking ahead, and I should be looking where I am. That's a dangerous thing, looking ahead. I'm thinking, God, what am I going to do next? Yes, this should have been a 7. Thank you.
No
Continue
worries.
to correct my ways. I need correcting. I'm not one of those people that's going to get upset like, oh, how dare you correct me? If I made a mistake, tell me. Okay. All right. Yes, what?
Okay, so I just have a question. So from the first line to the second line, it went from positive to negative, right?
Right.
For the negative, it was -6 plus 5mn.
Yeah. Okay.
So that went from negative, and then how come you put it positive on the bottom? So 7n squared plus 6mn.
Okay. So where did this come from? Wait, let's go to a red. Where did this come from? It came from this, which is one of those, plus 5 of those.
Oh, okay.
Yeah, this sign is attached to just the 6.
Okay.
This sign, yeah, the sign is immediately in front. So this subtraction sign is only attached to the 6.
To that one. Okay.
Oh, yeah. Okay.
Thank you.
All right. Anything else? All right. Another example. Let's say I have this. X squared plus y squared plus 3 plus 4y squared minus 7 plus 8x squared. Okay, let's say I've got that situation. So first of all, I can drop the first set of parentheses. Distributing the plus sign, I'm going to get the same thing I have in the second set of parentheses. Okay. Combining like terms, those go together, and those go together. So I've got 9x squared plus 5y squared minus 4. Now, is that standard form? Well, it's in standard form in terms of x squared, but I could also write 5y squared plus 9x squared minus 4, and that would be in standard form too. So here's the deal. If an expression just has one variable to different powers, then standard form is pretty cut and dry, descending powers. When it gets into more than one variable, then things get a little bit muddy, okay? And don't freak out about it. It's not like I'm going to give you this problem and say, write it in standard form and, oh, you did it this way and I wanted it this way, it's wrong. No, that's not going to happen, okay? It's going to be something where it's like all Y or all X kind of thing. And anyway, you okay with that?
So WebAssign won't, if there's a question like this, it won't mess us up because we had one or the other.
It shouldn't. It shouldn't. If it does, I'll hear
Okay.
about it from you and we'll take a look at it. But
Okay,
I haven't had
thank you.
Yeah, this is the fourth quarter I've been using the WebAssign stuff, and that question hasn't come up before, so I will probably be safe, but there's always a first time. We'll see. Okay, let's see here. Okay, suppose it says this. It says subtract 3y squared minus 6y plus 7 from 6y squared plus 4y plus 13. Tell you what, let's come back to that for a minute. Suppose it said subtract A from B. How would you write that? Would you write it like this, A minus B?
Yeah, B minus A.
Right. It would be B minus A. Subtract A from B. So you're starting with B and subtracting A, so it's going to be B minus A. All right. So here it says subtract this from that. Now, so this one's going to go first. What's wrong with this problem? What did I not do that I should have done?
You
What is
didn't
it?
add parentheses.
Yes, where?
On the second
In-
one?
Yes. Now, I can put one on the first one or not because there's nothing in front of it. But I've got to group that whole thing. It says subtract all of that. So I've got to subtract all of that, which means ultimately I'm going to get 6y squared plus 4y plus 13 minus 3y squared minus times minus plus 6y minus 7. So even though it's not grouped up here, because of the way it's written, subtract that, you've got to quantify it when you subtract it and ultimately distribute the subtraction sign through each and every term. Okay?
Okay.
Now that the grouping symbols are gone, we can combine like terms. 6y squared minus 3y squared is 3y squared. 4y plus 6y is 10y, and 13 minus 7 is plus 6. So here, standard form is clear because we're only dealing with the variable y. All righty. Questions here? Anything? Okay. Yes. I want to do a one that's got a picture because there's a question in the book like this that comes up, or in the assignment that students ask a lot about it. So hopefully I can give you a clear picture. It says jets. Find the polynomial that represents the length of the longer jet. And I'm going to apologize ahead of time for my great artwork. Okay, let's see. Okay. And here's, all right. So we've got that jet, and then we've got this one. Yes. And no, I didn't flunk art, but I probably didn't get an A either. Okay, now, here's what's down below. We've got this and this, and then there's this. And this says 9x minus 15 feet and 2x plus 3 feet. Okay. It says find the polynomial that represents the length of the larger jet. So the smaller jet, its length is 9x minus 15, the quantity feet. How am I going to get the length of the larger jet? What am I going to do?
You add.
Yeah, you add what? This length plus this length.
Yeah.
Okay. So you're going to have 9x minus 15 plus 2x plus 3, which is 9x minus 15 plus 2x plus 3, which is 11x minus 12 feet. Now, notice I put parentheses around the whole thing and then wrote the units. Because if you write this, that is saying you've got 11x minus 12 feet. And you want 11x minus 12, that quantity feet. So be careful with your labeling, okay? Now, I'm going to change this problem somewhat. And let's see here. Let's get rid of all of this. And let's say we've got this situation where this distance, we'll say, is 10x plus 4 feet. And this distance is, how about 3x minus 6, okay? Now, I want the length of the smaller jet. What am I going to do here? Oops, sorry. How am I going to find the length of the smaller jet?
You're going to subtract.
Yes, subtract what?
The 10.
The 3x minus 6 from the larger one.
Good, from, yes. So it's going to be 3x minus 6 from 10x plus 4. So 10x plus 4 minus 3x minus 6, right? Like that. So that's going to be 10x plus 4 minus 3x plus 6, which is going to be 7x plus 10 feet. So you see how that's working?
Yes.
All right. Let's see here. Okay. Here's some lookalike problems. We're going to take part A and part B. Part A says negative 8x squared minus 3x plus the quantity negative 11x squared plus 6x plus 10. Part B says negative 8x squared minus 3x minus negative 11x squared plus 6x plus 10. So in part A, because there's nothing in front of the first set of parentheses, you just write what's inside, bring it down. Since there's a plus sign in front of the second set of parentheses, you bring it down. You could write plus a negative 11 if you want, but it's the same thing as minus 11x squared, okay? And then combining like terms, negative 19x squared plus 3x plus 10. In the second group, the first binomial comes out, but then distributing the subtraction, we get plus 11x squared minus 6x minus 10, which gives us, let's see here, 3x squared minus 9x minus 10. So we get very different answers. So you've got to watch for the operation, okay? If a doctor does the wrong operation in a hospital, there could be a catastrophe, okay? If you do the wrong operation in math, there could be a math catastrophe. We don't want to have to write you a malpractice math, thing. Don't go there, all right? Okay, so tonight homework, 5.5. We'll have class tomorrow. I'll be here at 1:15 this afternoon, and I'll mention this tomorrow again, but next Monday, this coming Monday, is Martin Luther King Day. It's a holiday. There will be no class. There will be no Zoom meetings. There will be no Mr. Mayo calling you at all hours of the day answering your questions, okay? But I'll remind you again of that tomorrow. But anyway, so for tonight, section 5.5, and let's see here. Get my, I can find my mouse wandering around. I'll stop the recording.